Welcome to another episode of the 10-Minute Land Surveyor. I'm Dave Woolley. Today we're going to be talking about land surveying myths, and there are plenty of them. Let's get started. Myth number one, coastal water boundaries are 3 nautical miles off the coast. That's a myth. That hasn't been true since 1982. There was a territorial sea boundaries established in 1982 by the United Nations Convention on Law of the Sea. And there is a belt 12 nautical miles off the coast, and that is the boundary. Now, it was real common, and prior to 1982, it was common knowledge that the boundaries were 3 nautical miles off of the coast. Well, how did that ever be? Well, at the time that that was written, the extent of a cannon shot from land to the sea was 3 miles. Therefore, the boundaries were at 3 miles. Myth number 2, GNSS is the synonymous with 1 centimeter, because you'll see that there's several vendors out there, or particularly when you get out into the survey adjacent world, they don't call it GPS, they call it GNSS. And GNSS in their mind is 1 centimeter accuracy. And so you'll hear this often that we have GNSS and therefore we have 1 centimeter accuracy. Now, being land surveyors, you know this is a myth. The 1 centimeter accuracy, first of all, let's talk about the definition of GNSS. It's simply Global Navigation Satellite System. It has nothing to do with accuracy per se. So 1 centimeter, when you look at your GPS equipment rating, is 1 centimeter, does not account for any of the other sources of air that are in the GPS, in getting a GPS position. For example, it does not count the air in the bubble. It does not count the air of the parts per million. It only counts the receiver at the head. And so 1 centimeter also is only standard deviation. So that means that your 1 centimeter is probably true 68% of the time. That leaves you a full 32% of the time that it's not within 1 centimeter. And RTK is actually 2 centimeters, and that's at the head. It doesn't account for 2 parts per million, or which is the length of your baselines, or any other conditions. So when people say they have GNSS, they're saying they have 1 centimeter, and being surveyors, you know that's not true. I'll give you a bonus myth. Trembling is not a verb. This is something we laugh about, because if you talk to a plumber or a contractor or any number of equipment, people using Trimble equipment, they often refer to it as trembling. You say, well, how are you guys going to put in that building corner? Well, we're going to tremble it in. We're going to be trembling all of our underground in. So that's not actually a verb. That's a bonus myth buster. Myth number 3. Total station cannot measure accurately through glass. You see this instrument? Right here. What do you think that is? That's glass. It's not the EDM sitting out here on the face. So when somebody says that an EDM cannot measure accurately through glass, you could also point to one of these. If you take this apart, there's actually a glass lens over the beveled glass with a mirror in the back. So the fact that an EDM cannot measure through glass is actually a myth. It can. I'm a little surprised that more people haven't actually looked at the instrument and made that determination on their own. Okay, but let's caveat it. How an EDM works is it measures out a laser, and the laser travels out and back. That's why you have the mirror in the back. And the laser traveling through the Earth's atmosphere, particularly for short distances, is very consistent in time of flight out and back. And so if you're measuring through glass on your EDM, and you're measuring through glass in a building, and you're measuring through glass to your reflector, what is it that you think makes that glass any different than the other glass that it's actually always measuring through? Well, here's the deal. If you had beveled glass, if you had glass with some kind of treatment on it that you think might affect the time of flight of that laser, it may affect it. But if you shoot perpendicular to the glass and you measure through the glass, which I have done hundreds of times in my career, you will find that there's no distortion in your EDM measurements. But we don't like to do that as surveyors. We like to have a check. So here's how you check it. Usually when you find yourself measuring through glass, you're measuring from the exterior to the interior of a building, or from the interior of the building to the exterior of the building. We often traverse through buildings, and we'll be working our way through a building series of short back sites, short floor sites, and we're surveying up stairwells or something similar to this, or steel, whatever we're doing. And so what we try to do is we have control throughout the exterior of the building set, and we try to get into a room or to an out area where we can measure down to our control on the ground, or control on a parking structure adjacent, whatever, control to the exterior. So in order to check it, what you do is you measure into a room to the window, you measure to your control, then you continue down a hallway, for instance, maybe to the other end of the building, you measure into a room, and then you measure into the through the glass, try to hit to the same control point. And that's a check, because if your distances are bad, which is what you're worried about with the glass, you would have another solution there with an angle-angle intersection if you're running this through StarNet or TBC or something where you're processing. So you have other methods. So it'll test angle-angle, side-angle-side, distance-distance, and it'll come up with a solution. So if you had a distance that was subject to refraction measuring through that window, it would show up if you did a double determination on the control. And so we've done it, like I said, just hundreds of times and never had an issue. So that's myth number 3. Now, I imagine I'm getting close to my 10-minute video time. So I'm going to leave you with a few things to think about before I do my next myth buster. One of them is myth: always backsight longer than the foresight. That's true in really one instance. It's not true across the board. And so you'll hear a lot of people tell you, oh, always measure the long one. Ask them why that is. Next myth: traverse area of closure is anything more than a blunder detector. And we've all heard it. Somebody comes in and they say, oh, I closed 1 in 50,000 today. And you're like, oh my gosh, that's really good. Well, that doesn't mean anything. It really depends on how many setups did you have and how long were the legs. And then you can do the math, because it's just as likely to be an area of closure of 100th as it is to about 1,500ths on a 4-sided traverse with 500 feet on each leg, 2,000 feet total. And those two numbers are one and the same. We'll talk about why that's a myth. So, but I'll tell you this: if you get somebody really excited and bragging about they closed 1 in 50,000, leave it alone. Let them feel good about it. But in the back of your mind, know that that doesn't mean anything. Okay? It is legal for a land surveyor to use an EM locator and report the depths of utilities in California. That's not true. You cannot do it legally, and you'll get a citation from our licensing board if you do that. The only way a surveyor can determine the depth of a utility and report it is by measuring a pothole or dipping a manhole for an invert. It has to be an observation. It can't be what that EM locator reads. And the depths from those EM locators aren't consistent and aren't accurate. It really depends on soil types and other conditions. Kind of ruined that one for you, but that's a myth that you can write that down. If you're doing it, you better stop. The last myth that I'm going to bust and go into is I don't have to file a record of survey because I didn't set monuments. That's actually never been true. California's been licensing surveyors and requiring records of survey for over 130 years, and that has never been true. I'll go through why. So put away your clown shoes, pack away your mini bike, and don't fall for every myth that comes out of another surveyor's mouth. Thank you and have a nice day.